All right, let's talk a little bit about symbolic arguments. A symbolic argument has a set of premises and a conclusion, okay? And when we talk about arguments and logic, one of the things you have to be careful of is don't try to apply common sense here. We have to follow the rules of logic, okay? So we're not going to read an argument and go, well, that sounds right, so it must be, correct. No, we need to take an argument, put it in symbols, and apply the rules of logic. Because we're doing mathematical symbolic arguments here, so we got to follow some rules. Okay? Alright, so let's show you an example of an argument. If the cat is on the porch, then the frogs are hiding. The frogs are not hiding, therefore the cat is not on the porch. Okay? So in this example, the premises are the first two statements. Those are the givens. Okay, those two statements. And the conclusion is what follows after the word therefore. And what we're going to do in symbolic arguments is we're going to take our argument and write it in symbols. Okay, so the first statement was an if-then statement. So if P, then Q. Okay, and this one is not this one, so just showing you the setup for this one. We write the two premises, we draw a line, therefore is represented by the three triangular dots. Okay, so this is what are called arguments. These statements are the premises, that is the conclusion. The conclusion is what follows from the therefore. Now what we're going to have to be doing in this section is we're going to be determining if an argument is valid. To determine if an argument is valid, you don't just read it and go, yeah, that sounds valid. No. The first thing you're going to have to do is get the argument in symbolic form. So you write your premises and your conclusion all in symbols. Okay? Now, we are going to have some standard arguments that you're going to be able to compare to. If your argument is one of the standards, then you can see if it's valid or invalid. If it's not a standard, then we're going to have to write it premise 1 and premise 2, an if-then statement followed by the conclusion, create a truth table. If the answer column is all trues, then it's valid. If it's not all trues, then it's invalid. And of course, I'm going to go all through this in examples because I know I'm talking really fast, but it's sometimes hard to understand this when it's all written in words, and I prefer to show you examples. Let's start with some standard forms of arguments. Okay? These arguments, they have names, and somebody's already done the work for you and determined that they are valid arguments. Okay? So these are one of those that you want to write on a little note card, have them set aside, know that they are valid. So if you're given an argument that fits one of these, you don't have to work through all the truth table, you just compare it and go, yep, it's one of these, therefore it is valid. Okay? And I'll give you these on the final exam so that you don't have to, it's hard to memorize all of these and keep them straight in your head. So these will be given to you. And if you write them down, you'll have them during your test. Okay, this is one of our valid arguments. And one of the things I wanted to do was to go ahead and show you why it's valid. And I'm going to show you how it's valid by actually applying the rule of creating a truth table for the argument. Okay? Alright, so whenever you have an argument and you want to show that it's valid, the first thing you do is you write your first premise. That's my first premise, premise 1. And premise 2, which is not Q. Since these are my premises, I'm going to put them in brackets. Therefore, if-then statement, followed by my conclusion. Okay? So this is what you always do 100% of the time. Premise 1 and premise 2. Work that out. Therefore, conclusion. Okay? So you start off by working out each one of these, adding them together, work your conclusion, and then do your if-then statement. So this will always be your last step. Okay? So step number 1, let's do P implies Q. Remember the if-then? The only time it's false is when you have true followed by false. So if true, then true. If true, then false. False, true. False, false. Okay? I'm saying one thing and writing another thing. Okay? So if P, then Q, the only time it's false is if you have true followed by false. I need not Q over here. Q is true, false, so not Q is false, true, true. Okay, my next step here is to AND these two together. Okay, so notice that I did this second and now this is third. This is the AND. For AND, if there's a false, it's false. So true and false, false and true, true and false, true and true. This green is the answer to the brackets. Okay? Now, my next step is going to be not P. Well, P is true, true, false, false. Not P is false, false, true, true. Now, my last step is going to be to take the two green columns and apply an if-then. False, false, true. False, false, true. False, true. True, true, true. True. Remember with the if-then, the only way it's false is if you have a true followed by a false, which we never have. Okay? Look at my final column of this truth table. They are all trues. Therefore, this argument is valid. And this is one of our standard arguments, and it's called the law of contraposition. Again, mathematicians like to name things. You don't have to know the names, but that's why it's valid. Alright, so in this case, we're going to translate the argument into symbolic form and then determine if the argument is valid or invalid. The first thing we have to do here is change this argument from words into symbols. Okay? And we're going to look for simple statements in here. The first simple statement that I see is Cirilo teaches this course. So Cirilo teaches this course. Let's call that P. I will get a passing grade is Q. And notice I have an if P, then Q. So if P, then Q. That's my first premise. My next statement says I did not get a passing grade. Notice the word not. I get a passing grade, that's Q, right? So I did not get a passing grade is not Q. Notice the next statement has a therefore. Cirilo did not teach this course. Well, here we have the not. Cirilo teaches this course is P, so Cirilo did not teach this course is not P. Okay? Now, we could either make a truth table for this argument or compare it to a standard form. And if you remember our standard forms, you could see here that this standard form is right here. It's the one we just did in the previous example. It's the law of contraposition. So I don't have to do a truth table again. I could say that this is valid by comparison with the law of contraposition. Alright, these are some standard invalid arguments. We have the fallacy of the converse and the fallacy of the inverse. So if you're working with an argument and you translate it into symbols and it translates into one of these, you automatically know it's invalid because these occur enough times that they've got a name, and we've already done the truth tables for them, and we know that they are false. Okay? Now, let's take one of these, and I'm going to take the fallacy of the inverse, and I'm going to do the whole truth table to it to show you why it's invalid. Okay? So here is my fallacy of the inverse argument. And there's only 2 letters, so it's my standard 4-row truth table. And the first thing I have to do is to take it from argument form into truth table form. And remember how we do that? We take premise 1 and premise 2, bracket it, therefore, conclusion. Okay? So let's start with premise 1. If P then Q. Remember, if P then Q, it's false when it's true followed by false. Otherwise it's true. Not P. Well, P is true, true, false, false. Not P is going to be false, false, true, true. And now to finish my premises, I have to AND them together. Remember, with the AND, if there's a false, it's false. Okay? So this green column is my premises. My next step is to work on my conclusion, which is not Q. Q is true, false, so not Q is false, true, true. And now finally I do my last step, which is the therefore, and I'm comparing the 2 green columns. And remember, it's an if-then. So an if-then is false if you have a true followed by a false. Let's see, true, false is false. All the other cases, it's true. Now look at our answer column here. If these were all trues, this would be a valid argument. However, since we have one false statement, that makes the whole entire argument invalid. The only way to have a valid statement is to have all trues.